Dear students, I am happy to welcome you all to the course on Statistical Methods for Psychological Research Part 2. In this lesson, we are going to learn calculation of chi-square goodness of fit and one-way classification. First, we go with the objectives. After completing this module, students will be able to understand the concept of goodness of fit, learn the data presentations in one-way classification, compute the expected frequency using average, proportion and distribution, and also to apply the chi-square test for the suitable statistical data. Let us go with the objectives of this lesson. First, the student will understand the concept of goodness of fit, then learn the data presentations in one-way classification, also to compute the expected frequency using average, proportion and distribution. At the end, you can apply chi-square test for the suitable statistical data. Let us start with the first part of the lesson. We will be on classification of one-way frequency tables and procedures for getting expected frequencies. Coming to that one-way classification, one-way frequency tables are used to summarize categorical data by displaying the counts or frequencies of observations in each category or group. The classification of one-way frequency tables depends on the number of variables involved, whereas here you will be going on with an one-way classification which will be presented as the usual table, whereas in the next further lessons we can move on with the two-way classifications where you can make it as a contingency table. Univariate frequency table. This is the simplest form of a one-way frequency table where only one categorical variable is considered. It displays the counts or frequencies of observations in each category of the variable. Let us go with some examples. Suppose you are conducting a survey on the favorite colors of a group of individuals. You can collect the responses from 100 people. Let us make it as an example here. The categories are red, blue, green and yellow. Let the frequencies of the color choices are as follows: red with 25, blue with 35, green with 20, then yellow with 20. In this case, you have a univariate frequency table because you are examining the frequencies of single categorical variable, that is favorite color. As I mentioned, if you go for more than one category, then you can go for a contingency table, or you can call it as a cross table, whereas here you are fixing it with only one category, hence you can go with an univariate frequency. How to calculate the expected frequencies? You can go with these steps. So you are having the total sample size as 100, then you have the proportion of red as 25 by 100, that is nothing but 0.25. Similarly, proportion of blue will be 35 by 100, 0.35. Then proportion of green will be 20 by 100, 0.20, where you are getting your proportions for your colors. At the end, proportion of yellow will be 20 by 100, 0.2. Now, to calculate the expected frequency for each category, just you multiply your proportion with respect to your total frequency. That is, for expected frequency for red, you can move on with 100 into 0.25 as 25, then for blue 100 into 0.35 as 35, then 100 into 0.2 as 20, and the end yellow 100 into 0.2 as 20. Now we can see here observed frequency and expected frequency as displayed in a table here. You can see the values of observed frequencies are 25, 35, 20 and 20. Similarly, the expected frequency are 25, 35, 20 and 20. Here you can see the values as equal in observed and expected. Here the total number of observations are in 100, that's why you are getting it as an equal in number, whereas if you go for with different values, there may be variations between them. Now we can see here, if you compare these two, observed and expected frequency, usually you will be using a formula chi-square as summation OI minus EI whole square by EI. Now you can see here 25 minus 25. So every time if you go for the difference, the value will be 0. It means that your chi-square calculator will be getting it as 0. Here just I got it as a simple example, but in our real time you cannot get the value as 0. Now we can go with the next second example. Suppose you are conducting a study to determine if a 6-sided fair dice is truly fair or not. You roll the dice for 140 number of times and record the following observed frequencies for each phase. As you know, while you are rolling a die, there will be an phases with an 6, that is 1, 2, 3, 4, 5 and 6. Now you can see the frequencies. The phase 1, that is the die facing 1, has been obtained for 22 number of times. The die phase 2 has been obtained for 18 number of times. Then phase 3 has obtained for 25 number of times. Then phase 4 is for 28, phase 5 is for 19 and phase 6 is for 28. This is the total count here. To calculate the expected frequencies, you assume that the dice are fair and each phase has an equal chance of occurring. As we have been discussing on the assumptions of chi-square, that there should be an independence and that there should be an equal chance has been considered. Since there are 6 phases on the dice, the expected frequency for each phase can be calculated as expected frequency for total number of rolls divided by number of phases. You can see over here the total is 140 and the number of phases is 6, that is 140 by 6. The value is 23.33, that is your average value. Now your observed frequency and expected frequency has displayed here. You can see the first column is phases, that is your die phases 1, 2, 3, 4, 5, 6, and this is your observed frequency which you obtained from your question, that is your problem. Now the expected frequency has computed through the average. So totally you have been went for 140 number of frequency divided by 6 number of phases, you get the average as 23.33. It means that each and every phase will have the average chance of getting 23 number of times while rolling it for 140. So 23.33, 23.33 will be repeated for 6 number of times. So here in a previous example you have been went with the equal in number for observed and expected frequency where you have used for proportion. But now here you went with the technique of average, hence you have been moving with a different value and you have been specifying it as a same value. You can also understand with a simple example. I can say you that let it be in a 10 days there is 100 accidents happen. Let I give an example as let there will be a 100 accidents in 10 days. Then automatically you can think that for each day 10 accidents has happened. You can calculate it through your average, that is 100 by 10. But if you observe the count, there will be a difference. Some day there may be 12, some day there may be 8, some day there may be 9, but totally it will be 100. But you can expect that on an average there will be 10 accidents per day. That is what you have been using in this data. Dear students, now we come to the end of part 1 of this lesson. In part 1 we have discussed on the calculation of expected frequencies in one-way classification table, and we have also discussed on one-way classification table presentations. I am confident that you understood the concepts which you discussed here. We will continue in the next video. Thank you.